Give me just 1 second. Okay, tell me something about yourself in brief.
Sir, I am here, Dharmendran. I am from Teni in Tamil Nadu. I have completed my schooling in TMHNE Matriculation Higher Secondary School, and I have completed my BE in Tyagarajar College of Engineering, Madurai.
Okay, tell me favorite subjects for the interview. 5 favorite subjects.
Sir, thermodynamics, heat transfer, fluid mechanics, strength of material, and machine design, sir.
So, do you know about any plant in Tamil Nadu of NPC, like plant of NPCIL in Tamil Nadu?
So there are two plants in Madras Atomic Power Station and power station in Kudankulam.
Kudankulam and again, दूसरा. The second one?
Kudankulam. I think
No, Kudankulam.
Kudankulam.
Okay. There is any difference between in the Kalpakkam plant and Kudankulam plant?
Sir, I don't know, sir. I have no idea, sir.
Okay. Do you know about the LWR and PSWR?
So LWR is light water reactor and the PSWR is pressurized heavy water reactor.
Okay. So do you know about the which plant is LWR in Tamil Nadu?
In Tamil Nadu, light water reactor plant is light, sir. In Kudankulam.
Okay. Where is PSWR?
Sir, I'm not sure about the Kalpakkam plant, sir.
Yeah, Kalpakkam plant is PSWR and
Okay,
Kudankulam
sir.
plant is LWR.
Yes, sir.
Okay. So how you define the Newtonian fluid?
So Newtonian fluids are fluids which have constant viscosity and which viscosity is constant.
Viscosity is constant. And pseudoelastic fluids?
So sorry, sir.
Pseudoelastic fluids.
Sorry, sir. I can't understand.
Pseudoelastic fluids. Do you know
Pseudo,
pseudoelastic?
yes, sir. Pseudo
Plastic.
plastic fluids.
Yeah.
Uh, they are called as the shear thinning fluid, where when we apply shear, the viscosity of the fluid is decreasing in case of pseudoplastic fluids.
Okay. And what is the difference between the Newtonian fluid and Bingham fluids? You know Bingham fluids?
Yes, sir.
Okay.
Sir, in Bingham fluid, we have yield shear stress, some yield shear stress. But in case of Newton fluid, we have no yield shear stress.
Okay. Yield shear stress.
Yes, sir.
Okay. There's a like how you define fluid. What is the difference between fluid and solids?
Sir, in a fluid, uh, even without increasing the shear stress, we get infinite deformation. In case of solid, in case of ideal solid, if we give if we give even if you give infinite stress, there will be no deformation in case of ideal solids. But uh, that is in reality, actually, there will be some deformation in solid.
Good. So how you define Bernoulli? Bernoulli theorem. Do you know about the Bernoulli theorem?
Yes, sir. Bernoulli's theorem. Bernoulli theorem is the energy conservation.
Energy conservation. It's
Yes, sir.
based upon energy conservation. So from from Bernoulli theorem, like which quantity we can calculate?
So from Bernoulli theorem, we can calculate velocity, pressure, and datum height, sir.
Okay, great. So when we apply Bernoulli theorem, which were the assumptions we take?
Sir, we assume this flow is steady and it's along the streamline, and there is no external work and no viscosity.
No viscosity. And what is about the compression of fluid? Is compressible or not
It,
compressible?
it's incompressible, sir. Sir, we assume incompressible.
Okay. So we can't use fluid the Bernoulli theorem in compressible fluids. Can we use or not?
Sir, sir, no, sir, we can't use, sir.
Why?
Sir, in Bernoulli, we take the. So, sorry, sir, I think we can use. I'm not sure.
We're not sure. Okay. Okay. So tell me the three instruments which are based on Bernoulli theorem.
Sir, Venturi meter, pitot tube, and orifice meter.
Tube and orifice meter. So which quantity we measure from Venturi meter?
We can measure discharge from
Discharge.
Venturi meter.
Okay.
Yes, sir.
For pitot tube,
From pitot tube, we can measure the velocity, sir.
pitot tube is velocity. Okay. And orifice?
Orifice meter is also used to measure discharge.
This. From pitot tube we can't measure discharge.
No, sir. From in pitot tube, we can measure only the velocity at a particular layer, sir. Maybe in center line or uh, we can. So, for example, sir, in case of pitot tube, we can measure only the velocity at particular place. For example, when r is equal to 0 or r is equal to in the end or some place. So only by using pitot tube we cannot. I think we cannot measure the discharge, sir.
Okay. So in the pipe flow, how you define average velocity? There is a term called average velocity.
Yes, sir. Average velocity is equal to the maximum velocity divided by 2 in case of pipe flow.
No, no, no. I'm not talking about the formula.
Yes,
What is
sir.
the physical significance of average velocity?
Sir, average velocity is actually used to calculate discharge, sir.
Calculate the discharge. And
Yes, sir.
how you define the average velocity in pipe?
Sir, by integrating, sir, by some calculation involving the integration.
Okay. If we put the pitot tube and at the average velocity point, we gain the average velocity.
Yes, sir, we
Got
can
my
get the
point?
average velocity, sir.
And we multiply by the area of the pipe. We get the discharge, no?
Yes, sir, but yes, sir, we can get, but we cannot accurately keep the pitot tube there. It will be a difficult process.
Kyo? You don't know the where is the average velocity.
So, yes, sir, we have to calculate that,
Okay. At which radius we get the average velocity?
sir.
From the
I have to
center.
calculate,
Okay, calculate first.
sir. So wait a minute, sir. I have put charge for my laptop side running battery.
Okay.
Sir, the average velocity will occur at the point 0.707 times the radius of the pipe from the center. 707 times the radius of the pipe from the center.
Okay. So where we get the maximum velocity?
At the center line, sir.
So in the pipe, we call say the average velocity is the half of maximum velocity.
Yes, sir.
But when the fluid is flowing between two plates, what will be the average
Yes.
velocity in terms of maximum velocity?
So that will be average velocity will be 1.5 times of the maximum velocity, sir, in case of flow through two plates.
1.5 times.
Sir, maximum velocity is 1.5 times of average velocity, sir.
Okay. Okay. Do you know about the discharge coefficient?
Discharge, sorry, sir.
Discharge coefficient.
Discharge coefficient, yes, sir.
Okay. In like when we use benchrometer, pitot tube, and orifice, in which we get the higher discharge coefficient.
In venturi meter, sir.
Benchrometer. And minimum.
In orgis meter, sir.
Okay. Great. And come to some. How you define uniform strength beam?
Uniform strength. Uh, Sorry, uniform beam in uniform strength beam, the stress applied on every cross section of the beam should be equal, sir.
Stress applied.
Yes, sir.
How you can say that I applied a uniform stress on beam and it will call. This is the property of beam or this is the property of loading?
So it's the property of beam, sir.
Beam, sir. So how it can be dependent on my applied stress or applied force?
So, sir, so I think uniform that is uniform resistance, that is uniform strength given by the beam, sir, at the time when the load is applied. I think I'm not sure.
How you are not sure. Okay. You're like machine design. You
Yes,
tell
sir.
your favorite subject in machine design.
Yes, sir. But it's my least favorite subject, sir. I'm not very strong in that.
Is next okay. What is like anti-friction bearings?
Sir, anti-friction bearings. The types of anti-friction bearings are like roller contact bearings, cylindrical contact
No, no,
bearing,
no.
ADB.
How you just define anti-friction bearing?
So I think in the anti-friction bearing, we can neglect the work done by the friction.
But done by the friction.
Yes, sir.
So is there any friction in bearings or not?
Yes, sir. There will be friction.
Then why we call it anti-friction?
So, yes, sir, in anti-friction bearing, the pure rolling is will be occurring in case of the rollers in
Pure
the rollers,
rolling.
sir. Yes, sir. So in pure rolling, the friction work done by friction is zero. So there will be no effect of friction. So I think
Okay.
I'm
So we should call it na frictionless bearing, not anti-friction bearings.
not sure, sir.
Okay, leave it. We can conclude the interview. Like you have to good command in the FM part, the basic FM part, the fluid
Yes,
mechanics part. But like for
yes, sir.
like you have to know the terminologies and the reason if you use some word, what the meaning of that word, you have to know. Okay.
Yes, sir.
In any interview, if you use a new word, they will go at that new word. What the meaning of this? This is what the meaning of this. So use your
Okay,
words
sir.
precisely. If you know the things, then take this name. Take that name. Otherwise, just avoid it. Okay. You
Okay, sir.
take carefully. machine design, if you if you at least prepare for 5 to 6 subjects strongly.
Okay, sir.
Many times it happen. You take machine design at the last and they start from the machine design. And your
Okay, sir.
whole interview will be ruined. Okay? So take
Yes,
care
sir.
of about it. And for the HMT part, you have to go for the basics. For the meaning of why we use LMTD, just take law. I don't think
So
just
that question you
normal.
haven't asked me, sir. I think
Yeah.
that question is not. Even I don't know, but what's the reason, sir? I have.
Okay. If you go with the beginner, you get the answer. Why we take law.
Okay,
Okay.
sir.
Read it carefully and read the standard books so you can get the basics. Okay. Good.
Okay, sir.
And after the whole
Yes.
the interview, we can conclude we will take the all the questions and we will give the answers. Okay. So don't worry.
Okay, sir.
But read from the standard book, not just notes. So you can get the
Okay, sir.
depth of the subject. Okay, great.
Yes, sir. Yes, sir. Thank you, sir.
Thank you.